By the end of this session, you will be able to build a zoom lens feature like this one completely from scratch. You will understand how to implement the logic to move the lens smoothly, keep it confined within the boundaries of the image container, and accurately preview the area behind the lens in a separate preview box on the right. With that being said, let's dive in and break it down step by step. This is the view image inside this container, which is what we have in here. So we're going to start with adding the lens. For that, we have already this image that is going to be used as our lens. So let's add this in here. So here we're going to have an image. I'm going to give this an ID lens, and let's close. Okay, the lens is added. Now let's add some styles for our lens. Okay, lens, and we're gonna use 80 pixel. Okay, for the heights, and we need this lens to be moved freely inside this container. So position absolute. Let's refresh, and as you can see, it is added successfully. The next step is to add the preview section, which is the place where we need to preview the section behind this lens, which is the zoomed part. So let's add this preview box. And we're going to have another container, preview container. And finally, we can have the image. Image with ID preview image. Okay. And as you can see, this is the preview box. Now, the styles responsible to create this section, you're going to find them in here, preview box, preview container, and the image. Now, initially, these two components should be hidden from the viewport, and we need only to show these two components when the client hover over this section. So let's handle this. And for that, I already get this image container by ID, which is right here. So we're going to use this container dot add event listener. So the first event is mouse enter. So this mouse enter, we need to show these two components. But first, before doing that, let's hide them from the viewport. Let's go in here and give this a display none. And let's go to preview box and change this to none. Okay. Now, when the clients move the mouse inside this container, what we need to do, we need to show these two components. So I already fetched the preview box and the lens. So we're going to use these two constants elements to change the style to show them. So lens dot style dot display equal block, and preview box dot style dot display equal flex. Okay. We have something in here, lens display. So what we have here, image container mouse. So mouse enter, and yeah, it works. So now we need to hide these two components when the mouse leaves this section. So let's add this, which is the mouse leave. So image container dots add event listener mouse leave. Okay. And we're going to do the same thing. Just need to change this to none. Okay. None. And as you can see, it works. Now the next step is to make this lens follow our mouse. In order to do that, we need first to know the position of our mouse relative to this container. So for example, if I put the mouse in here, I need to get the point 0, 0. But we already know that to get the position of our mouse, we can use the event page X and page Y, which gives us the position of our mouse relative to the whole document. So let's start creating the event for the mouse moving. So mouse move image dot add event image container, sorry, dot add event listener for the mouse move. And here we need to specify the events. And let's close this. And here, what we can do, we can use page X, e dot page Y. Let's open the console. And as you can see, we get the position relative to the viewport. It's not relative to this container. So what we need to do in order to get the mouse position relative to this axe here, we need to get the position of this container and subtract the top and left from these page X and page Y. So let's do that. Now, in order to get the position of our container, we're going to use a special method. So this method is getBoundingClientRect, which gives us informations like dimensions and position of an element inside the document. So image container dot get bounding client rect. So let's first print this into the console and see what we have in this object returned. Let's comment this and let's move here. We have something here. I think I need to refresh. Let me reload the whole page. Let's open the console. And yeah, as you can see, we have these informations like bottom, height, left, and top, and width. So we're going to be concerned with this left and top because we need to get the position of mouse relative to the whole document and subtract the position of this container in order to get the position of mouse relative to this container. So let's do that. So here we have the position of our image container. Now we're going to get the top and left. So container top equal rect dot top and container left equal rect dot left. Then we're going to have lens left is going to be the page X minus this distance right here to get the position relative to this container. So lens left equal e dot page X minus container left. Okay. And let lens top equal e dot page Y minus container top. Now let's print these into the console and let's see what we have here. So let's just one, I think it's enough. So page top. Okay, so page top is not there. It's not page, it's lens top, sorry. Lens top, okay. And as you can see, we have the position of our mouse relative to this axe instead of the whole document. Now, all we need to do is to take these coordinates and use them as left and top for this lens because this lens is absolute, as we already mentioned. So let's do this lens.style dot left equal lens left. So we're gonna add pixel and let's do the same for lens top. Okay. As you can see, the lens is following our mouse successfully. But this is not actually what we need. So it will be better if the mouse is placed in the middle of this lens. So what we need to do in order to achieve that is to subtract the half of the width and half of the height from this dimensions of this lens. So we take this lens left and we're gonna subtract lens half size, which is the lens size divided by 2. So I hard-coded this value, which is coming from this dimension. So we're gonna do the same for the top. And now the mouse is placed in the middle of this lens. Okay, so now here we have some things that we need to do before previewing the section behind this lens. Now, if I move the lens in here, what I want to achieve is that if I move the mouse, a little bit to the left, I need this lens to be fixed by this border. So if I do it right now, as you can see, it is overflowing. So it will be better if this lens is fixed when it reaches the left border. So what we can do here, let me console.log the lens left. As you can see, here we have the coordinates of our lens in the left property. So as you can see, we have 8, 4, 2, and 0. So when the lens left reached 0, I need to fix it to 0, because if I move it in here, I get negative values. So what we can do, before assigning these values to left and top, I need to check if the lens left is less than or equal to 0. I need to fix the lens left to 0. So let me refresh the page, and as you can see, now it is fixed, as you can see, because when it reaches 0 or something less than 0, we need to fix this into the border. So we're going to do the same for top. So here, if lens top less than or equal to 0, okay, well, we're going to do lens top equals 0. Sorry. Okay, now it works. Okay. Now, in order to do this in here, in this edge, what we need to do is we need to get this position. So this position actually is equal to the width of our image container minus the length of our lens. Yeah. So when the lens reach this, we need to fix it to this position, which is the width of this container minus the width of our lens. So what we need to do is we're going to add if the lens left, which is the position of this lens, plus the lens size itself is greater than the length of our image container, which means if the lens is located in a place like this, we need to fix it into this position, which is the rect width minus the width of our lens. So let's do that. So here, let's add this condition. So lens left, yeah. So we're gonna add the lens size in order to get a position like if this position is actually greater than rect dot width, then what we need to do, we're gonna fix the lens left into this position, which is the rect width minus the lens left. Yeah. So rect dot width minus lens size. Okay. Now let's try this. And as you can see, it is fixed. Now we're going to do the same thing in here. So we're going to need to know this position. And then if this lens exceed this position, we need to fix it into this. So for that, we're going to add another condition. So this is exactly the same thing, just change the left to the top. So lens top plus lens size is greater than rect dot height. In this case, we're going to have lens top equal rect dot height minus lens size. So let's try now. And as you can see, it is fixed here as well. So we have our lens ready to be used. Now here, I just want to let you know that if I change these images here, I did two things. I changed the source of this view image to match the source of the image inside the button clicked. And I also do something else, which is I change this preview area image, as you can see, and set this image right here as the background image of our preview section, as you can see here. So I already assume that you already have this section in your app, but if you don't, you can take this and twist it or change the code to match your needs. But I just want you to know that the preview image will be used this image as a background image. So the next step is to set the background size of our image. Now to better understand this, let's open whiteboard. So let's say we have an image like this, an image that has these 4 squares, 1, 2, 3, and 4. And we have this preview box. Now, if the lens is placed here, what we need to show is we need to show the one here and something like this, 2 and 3 and 4, which means we need to multiply the background size by 2. So here we take this image and set the background size for 200%. So basically this 200% is used because the length of our lens according to the image container is the half. So we need to take this, let's say for example we have 100 pixel is the width of our image container and the lens is, let's say, 50 pixel. So 50 pixel according to 100, we can do 100 divided by 50, which is 2. You take this 2 and multiply it by 100 to get 200%. Yeah? So this is exactly what we need to do in order to get the portion that we need to focus on into this preview image. So we're going to do that. But the place where we need to do that is we need to wait for this image to load. And then we need to calculate this because we need this image to be loaded. So for that, we need to inject this equation inside this load event. So when the image finishes loading, we need to add this code. Now we're gonna need to use these measurements. So we already know that we can get these measurements using this this method here, get bounding client rect. So let's do that. So const rect equal image container dot get bounding client rect. And then what we need to do, we need to take this preview image and change the background size to this result here. So what we need to do, we're going to take the preview image and we're going to do style dot background size. And what we need to do, we need to take this and divide it by the size of lens and multiply it by 100 to get the percentage to show only the portion that is behind our lens. Open these and we're going to use, so here we're going to do rect dot width divided by lens size and multiplied by 100. and we're gonna add percentage here. So as you can see, it take the background position 0, 0. That's why it shows only this part. But basically, the section behind the lens is only section shown in our preview section or preview image. So it works perfectly. Now, the last step we need to do is to play with the background position, in order to show um, the portion behind the lens while we are moving our mouse. So believe me or not, we only need to add only one line in order to achieve our final project. Now, to understand how to calculate the background position of our preview image, let me give another example. So let's say we have um, our box in here, and let's say we have our lens in this position. Yeah. And also we have like 100 pixel for the width of our image container. And the distance between the left border and our lens is, let's say, 50 pixel. So here the position should be 50%. So how to get this 50%? We need to take this value, which is our lens left, and divide it by the width of the whole image container. So 50 pixel divided by 100 multiplied by 100. Yeah, to get it as percentage value. So this is exactly what we need to do. So let's do that. Let's go into our mouse move because we need to do this calculus while we are moving our mouse. So every time the client move the mouse inside this section, we need to do this, change the background position of our um, preview image. So let's do that. Let's go over here and let's do the preview image dot style dot background position, and we're gonna use actually left and top as we did with our lens. So for left, let me point to something really important because this is not 50%. So basically in CSS, what it does, if we have left equal to 50%, it aligns center the section and it places it in here inside instead of here. Yeah. So here in our left, what we need to do is, let me open these. And what we need to do, we're gonna take our lens left, yeah, and multiply it by 100 to get it um, as a percentage value. And I'm going to wrap these into, into parentheses. And instead of divided by the width of our image container, what I want to do here is I'm gonna divide it by the width minus lens size. This is really important because if we just divide it by this width, we're gonna get this in here in case of 50%. But what we need to do, we need to get it in here. So we need to take this from our width in order to get the correct position. So let's do the same thing with the top. Let's use this. I'm not used yet to QWERTY keyboards. That's why I do some. So we're gonna have lens, the same thing, just change, the left to the top. So we're gonna multiply this by 100 to get it as percentage value. And I'm gonna wrap these with parentheses and divide it by now rect.height in this case because we are using top here. So lens size. So let's refresh and let's see. We have something here wrong. Yeah, so I just forget to add percentages here and here. So let's see now. And as you can see, it is working perfectly. So to be honest with you, I used this like this, as I just mentioned in here, but it doesn't give me the correct position, as you can see with me right now. As you can see, this is not precise. Even if it looks like it's showing the precise, as you can see this in here, but it is not giving me the precise section behind the lens shown in this preview image. So when I get this lens size and subtract it from the width, I get the correct position. So it is working, and to better see the effect, not appeared correctly. And when we move this, we can see now the contents clearly. So this is how I managed to create this lens. You can use another logic or another algorithm, but this is how I used it.